Now let's talk about dry powder inhalers, how they are built. This is the dry powder inhaler on the left. It's called the reservoir dry powder inhaler. All the powder is in one reservoir. It's in here in the bottom, and it sits on a bag of silica gel to keep it dry. And every time you inhale it, it takes a bit of the powder and it goes up with venturi forces and goes into the mouth. It's called the reservoir, which means that all the powder is together, which means that if it gets clogged or if it gets caking, it's not good. Usually the API will be mixed with lactose to keep it stable. The discus, which is another typical one, is called split doses, because here you have I don't have the better picture, but every dose is packed separately in a double aluminum foil, and every time you inhale it, you get like a needle that punctures it, and you inhale only that powder, and this is where the powder is being better protected and the shelf life is longer. But both inhalers are very good, and they kind of took the market. Another type is the HFA suspension inhalers. Here you have a tank, which is called a canister, in which you have the HFA, hydrofluoroalkyl liquid, suspending the powder. And when you press it, you get a cloud of this mist, and the particles and the droplets are inside. Now, everything I said before about the rules of 3 microns, also true to the droplets. The droplets need to be 3 microns. And since we expect every droplet to contain several particles, this is why the particles need to be even smaller. So often you will see that the specifications for HFA inhalers are smaller. You need smaller particles than for dry powder inhalers. So for example, if in dry powder inhalers, they will tell you that the DO9 is up to 6 microns, here they will need it to be 4, even less than 3 microns. If you know anything about tablet manufacturing, you know that the dissolution test is the basic QC control to see that the dose is okay. And for inhalation, this is the impactor. The impactor is a series of holes in which we make the powder go. So what they do when the chamber is closed, they connect the inhaler here, they activate it in a certain airflow, and the powder goes through this maze of holes. Now, if you see these holes, they are quite familiar. You see here 1 hole, and then it splits to 5 holes, and then more and more. This is exactly the table that I showed you about diameters and number of tubes, okay? It's a very simple mechanical simulation, but it's very efficient. And here we have like vessels that capture can capture the particles, and then they know how much particles are stuck in each phase, and the particles that goes to the last phase, it means these are the particles that go to the lungs, and the specification is usually how many particles go to the lungs. Now, in practice, this apparatus measures something that is called aerodynamic diameter. Aerodynamic diameter is the diameter of the particle divided by the porosity of the particle, the density of the particle, which means that large particles which are porous will have actual smaller diameters. This is, for example, one specific budesonide formulation that contains porous budesonide, and the real particles are about 5 microns in length, but the aerodynamic diameter will be less than 3. And many times when you discuss with clients specification, you will see either they ask for the fraction of fine particles, which are these ones, or for the aerodynamic diameter. And now I go to the FDA guidelines that talk about formulation and handling of respiratory APIs. The guideline has many pages. I just picked for me the specific phrases about micronization, and it's quite impressive. I think this is where it's the most elaborate document from the FDA about micronization. So they have a lot of specific data about micronization, and we can learn a lot from that. So here are some quotes, and then I will analyze them in depth. First, the crystallinity of the drug substance can be affected by mechanical processing, including micronization. This can lead to generation of amorphous particles that are thermodynamic unstable, with tendency to convert to more stable crystalline state with time. We learned so many from these lines. First of all, the FDA understands that micronization leads to amorphization, so they will check that. Second, they know that if it's one amorphous, it can change the polymorph, for example, because it converts to more stable crystalline state with time. So they also understand the time effect and the stability issues. The second phrase, increased drug substance particle cohesiveness resulting from the presence of very small particles can adversely affect flowability, fillability, and dispersibility. What are these three? Flowability, that's for sure. Fillability means the ability to fill the inhalers in accurate form. And dispersibility means if the powder is really being dispersed in the body or they're being aggregated. So they talk about cohesiveness, which is related to amorphous surface, and also to the presence of very small particles. So you will see also a limit on the content of fine particles because of that line. The third sentence, if micronization is used to adjust the PSD, the in-process controls can include total duration of micronization. That's very important. Usually you don't see that. PSD of the incoming material, of course, feed rate, inlet air flow rate, air pressure, physical mechanical properties of the input material, number of times allotted of micronized, and reintroduction of carryovers from previous micronized loss. Now, this is a big issue. In many cases, especially companies are using standard airjet mills need to micronize the material more than once, sometimes twice. I hear about 3 and 5 times even. And then you have two issues. First of all is the total residence time and the number of micronization that affect the physical properties. And also the issue of carryovers from previous micronization lots, which means that if I micronize material twice, how well did I clean the micronizer between the micronization? Do I have carryover? Maybe I have particles that were already micronized 3 times. I don't know. So the FDA would look more carefully on processes where the material is being micronized more than once, and that's an important note. So if your client asks you how many times you micronize a material, it's not because of a whims, it's because of this line in the guideline. And then you talk about recrystallization of micronized material, uncontrolled particles, though growth, and then a conditioning step should be considered following micronization to allow conversion of amorphous to crystalline from under controlled condition of temperature and humidity, which means that the FDA acknowledged the very known phenomena that micronized material change their properties very quickly during the first 24 hours and then longer during storage. So it means that your client will be asking you how much time does it pass between micronization and analysis, how much time does it pass between micronization and by the time you ship it, and what are the conditions of storage and so on. And this conditioning step, we discussed it a brief in the previous meeting. I just mentioned that many companies let the material sit even 30 days before shipping. And of course in controlled temperature and humidity. So all this is just from 4 lines in a guideline of something like 20 pages. Any questions until now? I'll take this as a no. 2 more lines. Physical property of a drug substance and or excipients are usually modified before they are used in a formulation. Particle generation or modification processes can include spheronization, spreading, and micronization. Now, this is a tricky line because it means that the physical properties of the drug substance are modified before they are used on formulation, which means that the FDA sometimes will consider micronization not as part of the API manufacturing, but as either interim part between manufacturing and formulation, or even as part of the formulation. Which means that the clients, the pharmaceutical companies that are doing respiratory product will sometimes want to include a lot of data about micronization in their submission file. And this is something that API manufacturers usually are not very trained to do. And it comes as very strange demands from the client. And this is because in many cases, micronization is almost as part of the formulation. And you can see it in the next line more clearly. If a drug substance or experience is being micronized after received from a supplier, the process parameters for micronization should be described as part of the product manufacturing process, which means that if the client is micronizing himself, this product, or if you're a contract micronization company and you received an API from a client, you micronize it and you ship it to a client, it means that actually your process is part of the submission file. But in any case, even if you are the API makers, a lot of the data from your process will go into the client's submission file.